Hey everybody, Six String Supplies. Today I'm going to do a quick tutorial on how to wire up a tone control to have two different capacitors. So you can mix and match and play around with two different values using a push-pull pot. Now this is, it looks like a bit of a monstrosity, but it's actually very simple to wire up. So basically when the push-pull pot is in the down or the standard position, I have, it will be seeing one tone capacitor value. In this case, I've got 0.022. But when we engage the push-pull pot in the up position, it then sees a different capacitor value, and in this case I've got 1000 PF. But I guess the key to doing this properly, or the key to making it worthwhile, is to choose two completely different caps. I guess if you're using two values that are fairly close together, like 0.022 and 0.033 for example, the difference is going to be minimal. I guess you're better off using capacitors at two different ends of the spectrum, which is why I've gone for two completely different values there, mainly just to demonstrate the difference between the two. Okay guys, so I'm trying out a new format today. Rather than me frustrating everyone with the slowness of some of the main tutorials, I'm doing it in diagram format off the computer. If you don't like it, just let me know in the comments what you think anyway, and we can always revert back to plan A for future videos, which will always be the mainstay of this channel anyway. Okay, so how to wire up a push-pull pot so you can have two different tone caps. So I'll just start off just by going through briefly, as we have done this, covered this before, on how to read and understand a CTS push-pull pot. So the vast majority of push-pull pots will come in this format here. This is a classical looking push-pull pot, Bourne's or Alpha, and most wiring diagrams, mine included, use this type of format. Now this was drawn on Microsoft Paint about six years ago. As you can see, it's a bit raw and ready, a bit pixelated, a bit old school, and the CTS push-pull on the left was drawn on Paint 3D. So God bless technology. Anyway, these 6 solder pins on your push-pull pot, this red circle and arrow should actually be pointing to these 6 pins at the top here. So these 6 pins are identical to these 6 pins. So if you saw a diagram and you had to connect top left to bottom right, you just translate that across to the CTS push-pull, which is again this one, number 4 going down to number 1. But the beauty of push-pull pots is that CTS pots, excuse me, they're a lot easier to use simply because they're connected to these holes in the form of a printed circuit board. So if you had to go diagonally from 4 to 1 there, you'd just use a jumper wire connecting hole number 4 to hole number 1, and it's as simple as that. So how do they actually work? Well, exactly the same as a normal push-pull pot does, or double pole, double throw switch does. So basically the 2 pins in the middle here, C1 and C2, are common, which is what the C stands for. They are always on. So if the switch is in the down position or the up position, the common lugs are always on. It's a bit like a strat switch. The common lugs either end of the switch are always connected, regardless of what position it's in. So when it's in the down position, as on the left here, C1 and C2 are connected, as are 2 and 4. So 4 connects to C2, 2 connects to C1, and that's both sides of the switch. And these yellow circles there just highlight really that they're connected. When the push-pull pot is in the up position, when you've engaged it, again C2 and C1 are on, but 3 and 1, the 2 at the bottom here, are also on. So C2 connects to 3, C1 connects to 1, and again these yellow circles demonstrate that. So we'll start off with a blank canvas. Let's assume this is a tone control, a master tone control going into a Telecaster. So you've only got the volume control opposite it, and this is the tone control. So that yellow wire at the bottom here is what comes from the volume, assuming we're talking about a Telecaster here, and that goes into the output lug of the tone control. That's the middle, and all we need to do is connect the pot to the the switchboard. And we'll just use a jumper wire connecting the sweeper to C1, but then we need to connect C1 to C2, which connects both sides of the switch. So we just have a jumper wire from that hole, C1, all the way across to the other side of the switch, C2. Next you choose your first capacitor. So this is when the switch is in the down position, so this will be the cap that you use the most. So I'm guessing if you're using a Tele, you'd use a 0.047 or 0.022 depending on your preference and your pickups. And all we do is we connect one end of the capacitor to holes 4 and 2. So you'd have the lead on a CGS push port. It's not quite as simple as just going straight across these two. You put one lead into hole 4, and then you'd use a jumper wire to connect 4 to 2. And the other end of the cap goes to ground, so you just solder that to the side of the pot casing. So how does that work? So when it's in the down position, we know that C1 connects to 2 and C2 connects to 4, but because we've connected both sides of the switch together, these are all connected. So the signal comes in from the pot, it goes into one side of the switch, which is automatically connected to the other, and because we're in the down position, we know that holes 2 and 4 are activated, which is why the cap goes into those two, and then the other end goes to ground, because obviously that's how a capacitor works. As you roll back the tone control, it gets bled down to ground. Next you move on, you choose your second capacitor. Now I'm guessing the best way to make the most of this mod, or to make it worthwhile, is that you don't want two capacitors that are very close together. So personally I wouldn't go for a 0.022 and a 0.033. I'd go something completely different. So I'd either use a 0.1 UF, which is a fairly bit of a darker tone, which would actually be quite nice on a Telecaster, or you could go to the complete other end of the spectrum and use something that's a bit more of a bleed circuit actually. Not quite sure how much of an effect that would have though. But now we're doing the opposite, so we're connecting one end of the capacitor, excuse me, goes into hole 1, and then again we need to connect that across to hole 3, and the other end of the cap gets soldered to the pot casing to ground. So again, as you dial down the tone control, the treble gets bled out to ground. And there we go. So when it's in the up position, we now know that the common lugs are on anyway, but 1 and 3 are also connected, which is why we connect the capacitor to holes 1 and 3, the yellow circles here. At the same time, because it's in the up position, 2 and 4 are no longer connected, so this capacitor is completely is rendered useless as such. And there's the final diagram. This is available on our website. I'll put the link to it in the description below, as well as a few other CGS wiring diagrams. That's it really, guys. I mean, I guess this really is a bit of a case of trial and error. So you choose for the first capacitor, when it's in the down position, you want to choose your main player, typically a 0.047 or 22, depending on your pickups and your preference. But then the second capacitor is where you can really have a bit of fun, choose something a bit different, and that just gives you a whole extra tonal dimension to your playing just by using a push-pull pot. Anyway, there you go, guys. That's the end of the video. Thanks very much for watching. Let me know what you think of the new format. It's actually quite nice to do it from a computer and a microphone rather than getting down and dirty with a soldering iron. If you have any questions or comments, please don't hesitate to get in touch, and we'll see you real soon in the next video.